Hello, students, and welcome to the first day of some actual math. Hooray! You guys are all so excited, I'm sure. Having all summer off without doing any math. But we're going to be nice and easy to you guys. We're just going to talk about one kind of two-step equations there, but they're not real two-step equations. And I'll go over that in a second. But basically, the idea here is just to go over something you guys should already know to kind of get you back in that math mindset. Again, one-step equations, you guys started in sixth grade, I think. So, and definitely have covered them the last couple years in seventh and eighth grade. So this should be pretty good review for you guys right now. So before we get into one-step equations, just solving equations in general, we need to talk about the operations and their opposites because that's very important. So when we talk about math, operations are like those things that you're doing to the numbers, right? Or you're adding them, subtracting them, so on. Those are operations. And there's four general operations that you go through generally every time you solve an equation. And that's addition and subtraction, as well as multiplication and division. Okay? Now, in order to solve equations, it's important that you understand the opposites. Okay? What operation is opposite to the one you're in question? So if I was talking about addition, if I add 3 apples to the opposite of that would be subtracting 3 apples, right? So addition and subtraction are opposites or inverse operations, as we say in math speak. And it's the same idea with multiplication and division. The opposite of multiplying something is dividing it, and vice versa. If I multiply by 3, the opposite is dividing by 3, right? So those are opposite operations. Now let's look at an equation. So let's look at just a simple one-step equation. So let's say I have x plus 5 is equal to 8. Okay? Now anytime you're solving any type of equation, doesn't matter what the equation is, but the important thing that you need to do with any equation is get the variable all by itself. Okay? Our goal is to get that x all by itself on one side of the equal sign. So there can't be anything on the same side as the equal sign. Once we have the x by itself, we're done. We've solved it. Hooray! So, looking at our problem here, we have this plus 5 on the same side as the x. So I need to get rid of this 5 here. Now, in order to do that, I need the opposite operation. So we have a plus. I need the opposite operation of a plus, which is subtract, right? Taking away 5. So if I want to get rid of this plus 5, I would subtract 5. And that would cancel out the plus 5. And it would be gone. X is all by itself. Now, I can't just say x is equal to 8 because that would be a whole different thing because I already know x plus 5 is equal to 8. So here's the trick with equations. This is usually the step that some students miss when they're moving too quickly, is whenever you do some operation to one side of the equation, means one side of the equal sign, in order for it to remain equal, you have to do that same operation to the other side. Otherwise, you're just taking away from this side, and that makes it a whole different equation. It would no longer be equal, okay? So if I take away 5 from this side, 8 minus 5 is 3. That leaves me with x is equal to 3. The x is all by itself. I'm done. Right? That's a long way of saying you just do the opposite operation to both sides. So what if it's plus 5 here? You do minus 5 to both sides. And that's it. You're done. Okay? So not too tough today. Let me go through quick examples of each type and talk about the two-step problems that you're going to see. So let's do a subtract. So let's do a smiley face variable because, you know, we're happy. Minus 4 equals 10, right? So minus 4, what's the opposite of subtract? Well, it's addition, right? So I would have to add 4 to get rid of this minus 4. And then if I add 4 to this side, I have to also add 4 to this side. And I'm left with smiley face is equal to 14. And that's my answer. Not too tough, right? Let's try another one. So let's say I have, let's do x over 3 equals 12. Okay, now this is a fraction, right? So fractions are basically how we have been writing division for years now, right? This means x is being divided by 3. So I need to know the opposite operation of division. The opposite operation of division is multiplying, right? Now I'm going to show you why this works. Whenever I multiply a fraction by a whole number, so by 3, okay? These are going to cancel out. And again, if I do something on one side, I have to do it to the other. But this is why it cancels out. So if I'm multiplying by a whole number, this is actually 3 over 1, right? And the top multiplies with the top, the bottom multiplies with the bottom. You end up with 3x over 3, because 3 times x is 3x, 1 times 3 is 3. Now, what's 3 divided by 3? Well, it becomes 1. 1 times x is x. So it ends up canceling out. That's why when you multiply by the same number in the denominator of a fraction, they cancel out. Okay? So those are canceled out, and x is going to equal 12 times 3 is 36. And that's your answer. Okay? Not too bad, right? Let's try another one. Let's do 4y is equal to 24. Okay. Now, this is something that some students still struggle with a little bit in 9th grade. There's no operation symbol here, right? It's just a number and a variable. There's no space. They're just right next to each other. Well, in algebra, whenever we know a variable is going to be multiplied by a number, we don't need to put the operation there anymore. Okay, we can just know that that is 4 y's. It's 4 times y. That's also saying is y plus y plus y plus y, right? So we just put the number there. So if you ever see a number right next to a variable, those are multiplying. So when we know multiplying, the opposite of multiplying is division. So to undo this 4 times, I have to divide by 4. And you divide it to both sides in order to keep it equal, right? These 4's cancel out. Y is going to equal 24 divided by 4 is 6. And that's your answer. Okay? Not too bad. Now, the 2-step problems you're going to see are going to be something like this. So let's say I have 5 minus x is equal to 2. Okay? Now, we have the x right here, right? There's no operation in front of this 5. We always look at the sign in front of the number when we're thinking of adding or subtracting. Okay? So because the operation is behind it, that subtraction is actually going to the x. So this 5 is actually positive. So if I want to cancel out the 5, I have to take away 5, right? So I would end up having to subtract 5 from each side. Okay, and that cancels out, and you are left with negative x is equal to negative 3. Okay, now is the x by itself? No, it's got this negative in front of it, right? You can think of it as negative 1 multiplying with the x. I have to have the x all by itself. So since I have a negative 1 multiplying with it, I have to get rid of the negative. You can't have a negative variable at the end. So all this does is just change the signs on everything. The negatives cancel out there, the negatives cancel out there. X is going to end up equaling 3. And that is your final answer. And that is 1 and 2-step equations.